now on to number 15. So we look for value of n for which the system has one real solution. All right, so this is one where if it were multiple choice, I would definitely use Desmos. But I'm not going to because I don't want to take the chance that I'd have to use a slider and the answer could be bigger than 10 or it could be a decimal, and I don't want to have to go through that. So then my backup option is I know that I can just use the discriminant. So I'm going to plug in 4 here. So I get 4 equals x squared plus 12x plus n. So I'm just doing like substitution. Then I have a quadratic that I want to equal 0. And then I'm going to use the concept that when I want to know the number of solutions to a quadratic, then I look at the discriminant. And b squared minus 4ac has to equal 0 if we want there to be one solution. That's because that's what's under the radical. And if you were doing the square root of radical in the quadratic formula, you'd be doing the square root of 0, and square root of 0 is 0, and plus or minus 0, it doesn't change anything, so you get one answer. So my b squared is 12 squared, so I get 144. Minus 4, a is 1, c is n minus 4. This is the entire constant. And then I'm just solving this. You could hop over to Desmos now if you felt like it to just solve this. I am going to do it this way. I'm going to bring the 4 times n minus 4 over, divide by 4, and get 36 equals n minus 4. So add 4, so the answer is going to have to be 40. So again, if I had used Desmos, I mean, the odds that I'm going to just make it up to like 40, again, guessing and checking and see how things move, you might have a really good feel of that, and you can get 40. And if you could do that quicker than I can do this, then go for it. But I really don't love using Desmos on these types of problems with sliders where there's no multiple choice. I like to use the actual like kind of conceptual way or school way to do it. So again, both are important to know.